Ever look at a math problem and feel your brain just shut off? All those letters and symbols can look like a foreign language. Beneath all that intimidating notation, algebra is actually a very simple method for finding a hidden number. The letter x acts as a blank box, a simple placeholder waiting to be filled with the value we are looking for. Look at this. Blank box plus 3 equals 7. You already know the answer is 4. You just performed algebra in your head. Think of algebra as a shorthand language for solving the kinds of intuitive problems you encounter every day. To see this shorthand, look at the golden rule of equations. The equal sign is the center pivot of a balanced scale. Our unknown x block and the 3 block on the left weigh exactly the same as the 7 block on the right. If you take the 3 block off the left side, the scale instantly tips. The sides are no longer equal, and the rule of the equation is broken. To find the value of our unknown block without breaking the scale, we must isolate it using inverse operations. This means we perform the exact opposite action of whatever is happening to the variable. To undo a plus 3, we subtract 3 from both sides at the exact same time. The positive and negative 3's cancel out, leaving our x perfectly balanced against a 4 on the right. Solving an algebraic equation is a mechanical process of removing weight equally from both sides until the hidden number stands alone. Let's apply this balancing act to real life. Imagine you check your wallet after spending $300 on bills and see you have $500 left. Translate that into this algebraic equation. Use x for your starting money, subtract the $300 spent, and set it equal to the $500 remaining. Perform the opposite of subtraction by adding $300 to both sides. This isolates x, revealing $800. This works for multiplication too. Imagine a mother is exactly 3 times as old as her child, and the mother is 39. Here is the mathematical structure. 3 multiplied by the child's unknown age, x, equals 39. To isolate the x, we perform the opposite of multiplication and divide both sides by 3, revealing the child is 13. Whether you are budgeting money, scaling a recipe, or calculating age, algebraic equations are real-world situations stripped down to their essential mathematical structure. Because the system relies entirely on balance, errors occur when we lose track of that equilibrium. One common trap is working on one side of the equation while forgetting the other. If you try to isolate x by subtracting 4 from the left side alone, the statement is no longer true. You have broken the factual reality of the equal sign. The second trap is mixing up the inverse operations. If your equation is x minus 5 equals 10, and you mistakenly subtract 5 from both sides, you move further away from your answer. You must perform the opposite action, which is addition. Success in algebra relies on strict fairness to both sides. By correctly reversing the mathematical actions on the left and the right, you will always find the value you need. Let's put this into practice right now. Look at this equation. X plus 5 equals 12. To get x by itself, we look at the plus 5 on the left and perform the opposite action. We subtract 5 from both sides of the equal sign. 12 minus 5 is 7. X equals 7. You just solved an algebraic equation on your own. It really is that straightforward. These letters and symbols provide a logical system where every move follows a clear rule. Once you know how to handle the symbols, the path to the hidden number becomes obvious. As you move into more advanced math, you can rely on this predictable, logical path. Treat both sides fairly and trust the balance.